As it said here, our lesson is 12.2a. We're simplifying radicals. And so what we're going to do is we're going to use the properties of radicals, understanding what a radical is. And a radical is just another way of describing a square root. And we're going to use those to simplify radical expressions. Here in algebra 1 and in geometry, we're going to have just whole numbers. We're not going to be having any variables involved with those. So it's really just radicals, but I use the word expressions there. So you guys should all be getting your notes. And if you notice at the top of the notes, the first thing we list are the properties of radicals. These are the rules that you're going to follow. So for an expression to be in simplest radical form, and that's truly what you're trying to do with each of these, is to put this in simplest radical form, you have to make sure that you have no decimal answers. So ladies and gentlemen, those of you who went to your calculator and typed in square root of 45 and wrote down 6.708, you would get no credit. So we really aren't relying on our calculator for much other than multiplying and then to use a check. So we can't have any decimal answers as our final answers. Then what we have to remember is that there's no pairs of factors underneath the square root. And what a pair of factors would be is 2 times 2, 4 and 4, 3 and 3. You can't have 2 of the same factor. I can have 2 and 5 still underneath the radical because they're not a pair. They're 2 separate numbers. And so we can't have pairs of factors underneath the radical. The reason for that, ladies and gentlemen, is that if you have a pair of factors, you've made a perfect square. So the other way to think of this rule is that there are no perfect squares in the radical. Because if the perfect square was underneath the radical, you could simplify it. So I'm using this word perfect squares. What is a perfect square? Someone give me an example of a perfect square. Julia? A 9. Now why did you choose 9? Because it's a perfect square, but how do we know 9 is a perfect square? What about 9 tells us it's a perfect square, Matt? Yeah. 9 is 3 times 3. We did 3 times 3 to get 9. 81 is a perfect square because you can do 9 times 9. What's our smallest perfect square? Ryan? Is it 1 or 4? 1. Because 1 times 1 is still 1, right guys? That's a perfect square. We usually don't do much with that one, ladies and gentlemen. We don't see 1s very often in this problem. So the smallest one you'll actually be using is what Ryan said is 4. These are a good list to have, ladies and gentlemen, because anytime I can use perfect squares, anytime I can make a factor tree, so that's what we're going to be doing today is making a lot of factor trees. Anytime I can use these perfect squares in my factor tree, it helps me out. What would come after 9? Or what would come after 4? 9. What would come next? 16, because that's 4 times 4. What would come after 16? 25. Let's start writing these down. I'm not giving you options. I'm telling you what to do now, ladies and gentlemen. What comes after 25? 36. What would come after 36? 49, because that's 7 times 7. What's coming next? 64. What comes next? 81. What comes next? 100. What comes next? 121. What comes next? 144. And last but not, this isn't our last one, but this is the last one I'm going to have us write down. What comes after 144? 13 times 13. Type it in. 169. Now, ladies and gentlemen, I doubt many of you are going to be using 169 in your factor tree. But the reason I write those down is, one, those are nice numbers to know to be able to take the square root right away. If I give you a problem that says square root of 169, you should not start breaking that down. You should immediately take the square root of 169 as 13. So we want to be able to recognize these perfect squares where we can. which is why this list is nice to have. But what we're going to do is, because we're talking about these factors, we want to start breaking 45 down into two factors. So what are two numbers that can multiply to give me 45? Julius? Oh, and I love 9 and 5. Why do I love 9 and 5? Well, because Julius told me yes, and I love all of Julius's answers. But why else do I love 9 and 5? Miss Gemma, what did we just get done writing down? A list of perfect squares. Was 9 on that list? Yes. Anytime you can find a perfect square, ladies and gentlemen, when we're simplifying these radicals, you are making your problem just a little bit easier. Because 9 breaks down into what? 3 times 3. And remember, ladies and gentlemen, what I'm trying to look for are pairs of factors, because those are what come outside the radical. It says no pairs of factors underneath the radical, so that means once I find a pair, I need to take it out. So I'm going to circle this pair of 3's. 5 does break down, but it breaks down into 5 times 1. And like I told you guys, we're not going to use 1 in our factor trees. So 5 just stays the same. It doesn't break down. And so once I find a prime number, I underline it, so I don't lose track of it, but I'm not going to break it down. What I do at this point, ladies and gentlemen, is I pull out the pair of factors. I have a pair of 3's. It comes out as the number 3. Even though I circled 2 of them, it only can come out as a 3. And the reason for that, ladies and gentlemen, is where did these two 3's come from? 9. And what is the square root of 9? 3. Even though they were under here as a pair, they were going back up to that 9, and the square root of 9 is 3. Okay? So once you circle a pair, you can only write it down one time for that pair. Now you still have your radical, and what number did you have left underneath? Well, what did we underline? What number didn't pair up with anything? 5. So ladies and gentlemen, this is what we call a simplified radical. 3 square root of 5. Now, I'm a big advocate for giving you guys the power to check your answers whenever I can. So if you have a calculator, it does not have to be graphing, but if you have a calculator, I'd like you to get it out. And let's take a look at what that check actually looks like. The problem was square root of 45. So I'm going to type in the original problem. The value of the square root of 45 is this decimal value. We can't write that answer down, but I know that that's the decimal value of square root of 45, which means anything I simplify, any answer I say is in simplest form, needs to have that same value. Well, I don't have my board up here right now, but what answer did we simplify it down to? What did we say was the simplest form answer, Abby? Good job. So you're going to type it in exactly the way it looks. 3 square root of 5. Hit enter. Ladies and gentlemen, are these the exact same answer? Which means 3 square root of 5 is the simplified form of that original answer, or the original problem. You can't give me those decimal values. These decimal values are simply for checking and making sure that you kept the same value. Okay? Any questions on that first one, ladies and gentlemen? Where did the 3 come from? From that square root of 9, from that pair of 3's. Where did the 5 come from? How did we decide to put a 5 underneath there? Because 9 times 5, and did 5 have anything to pair up with? No. So my singleton stayed underneath. That pair came out from the square root of 9. All right, let's take a look at 150. What could we break 150 down into? At your table, share an answer, come to an agreement. There's a number of ways we can do this one, and I actually think I'm going to do it 2 times. All right, Julius, what were you going to break it down into?
25 and 6.
25 and 6. Did anyone have a different way that they were going to break it down? Matt? 5 and 30? All right, ladies and gentlemen, we're going to do dueling radicals. We're going to see which of those gives us the right answer. like them both right now. I like 25 because what's 25? A perfect square, so what can I break that down into? 5 times 5. So there's my pair of 5s that are going to get taken out. What does 6 break down into? 3 and 2. Those can't go any farther, so I'm going to underline them. Those are those singletons. All right. Dueling radicals. Let's go do the other one. 5. Can I break 5 down? 5 I can't break down. No. Can I break 30 down? What could you break 30 down into? I heard 5 and 6. I'm going to go with 5 and 6. Ladies and gentlemen, is this a pair of 5s, even though they came from 2 different spots? Is it still 5 times 5? So could I circle those pair of 5s? Oh, yes, you can, and you better. And what can I break down 6 into? 3 times 2. Ladies and gentlemen, they started out quite different, but do they look exactly the same right now? Do both of them have a pair of 5s circled? Yes. Do they both have a 3 underlined? Do they both have a 2 underlined? Does either one have anything else underlined? Or anything else circled? The reason I did this problem this way, ladies and gentlemen, is to show you it doesn't matter what you first start with. As long as you break it down to find pairs, we're still going to come up with the same answer. Julius has 5 square root of, how is Julius going to write this? What do we do with the 3 and the 2? Bless you. Times them, because what does it say right here? 3 times 2. Multiply them together and get 6. What was Matt's table going to get? Well, they still had a pair of 5s. And what does it say to do with their 3 and 2? Multiply them and get 6. Ladies and gentlemen, I did this with my first hour, and I want to do it here again and just show you another example of this. This is square root of 150. Now, some of you are saying, I don't know any of my multiplication tables. I don't know anything that divides in there. Ladies and gentlemen, you all know that anything that is even is divisible by what number? 2. So I could have broken this down into 2 times 75. Now, 75 is not even, but what can 75 break down into? 5 and 15. Now, what can 15 break down into? 3 and 5. Ladies and gentlemen, even though the 5s are really far apart, is it still a pair of 5s underneath here? Yeah. Do you still have a 3 by itself and a 2 by itself? Yeah. The placement of the numbers looks very different, but is it still one pair of 5s and a 3 and a 2 left over? Yeah. Yes. There's no way that you have to start these problems other than with 2 numbers that will multiply to give you 150. Okay, guys? And I want you to recognize that even though 5 and 5 were in 2 very different parts of the problems, they still come together to make that pair. All right? Let's take a look at the next example. We still have our wait, are we on our, did I miss a page, guys? Three and 4. Somehow I deleted that page, ladies and gentlemen. Let's write those in my hand. The square root, for example 3, we're looking at 3 square root of 50. Ladies and gentlemen, what 3 square root of 50 means is that you're going to take 3 times the square root of 50. So we're going to treat this radical, the square root of 50, the way we did the other 2 problems. It's just at the end, I have to multiply our answer by 3. So this 3 just kind of makes its way down to the end of the problem. Okay? What can I break 50 into? What are 2 things that multiply together to give me 50? 5 and 10. I like that. Were there other ones out there, guys? Yeah. 2 and 25 would work. 5 doesn't break down. What about 10? Does 10 break down? 5 and 2. Even though these 5s didn't come from the same number, can I still pair them together? So, Mr. Calendar, I had a pair of 5s, correct? So, what's going to be, and then a 2 by itself? What gets pulled out of my radical if I have a pair of 5s and a 2 by itself? The 5s get pulled out. The pair is what gets pulled out, so this gets pulled out as a 5. What's going to stay underneath the radical, Renise? 2. But remember, guys, I told you you have this 3 here that needs to get put in there, and you're simply going to multiply 3 times 5, and so we get 15 square rooted 2. Now, I do want to make sure that you guys check these, or know what it looks like to check them. So I'm going to go to my calculator, and I'm simply going to type in 3 square root of 50, and I get a decimal answer. We said that our answer was 15 square root of 2. Did we get the same decimal answer for both of those? Beautiful. All right, example 4 now. Let's take a look there. Example 4 is 4 square root of 80. All right, so 4 is going to come down here. Katie Harlan, what can we break 80 down into? 4 and 20, I like that. What can I break 20 down into? 2 and 10. We can break this down into 2 and 5. Can my 4 break down? 2 and 2. So ladies and gentlemen, I see a pair of 2's here that we got from the 4, and that makes sense because the square root of 4 is 2. So we knew we should have a pair of 2's there. Is there anything else I can circle up or pair up? The 2 and the 2. Good job. So let's not blurt out any answers, so I'm going to give everyone else a chance to think. I do appreciate all that. And I'm not going to raise any hands. I want everyone at their tables to talk. I want you guys to, at your tables, figure out what all is coming out from underneath this radical. So quickly at your tables, talk and discuss what's going to come out. And I'm going to ask a table to share what they think is coming out. All right, ladies and gentlemen, back up front. Tyler, what did you guys decide was going to come outside the radical? I like the 2 from here. Did you guys pull anything else out? The other 2. This 2 comes from the first pair. The second 2 comes from the second pair of 2's. Each pair has to be represented outside the radical. Because this 2 came from, these pair of 2's came from the square root of 4. These 2's came from the 20, so I have to represent it. And then what's underneath the radical? 5. The red 4 came down from the beginning of the problem. So 4 times 2 times 2. Oh, did I make a mistake somewhere? Oh, okay. 4 times 2 times 2. Do you have an answer for me?
Yeah.
What is it? 16. Square root of 5. All right. What else did you have to say?
Me and Ryan did it. We broke it down to 16 and 5.
Beautiful. I want to show you guys what he's talking about here. He did for 80. Let me add another page in there. And that's what's cool about these problems, guys, is there's a lot of ways of doing them. I like this 16 times 5. I like these perfect squares because what can 16 break down into right away? 4 times 4. And I can stop right there, ladies and gentlemen. Even though those 4's still can break down, did you find a pair of numbers? Yeah. It doesn't say you have to find a pair of prime numbers. You just have to find some pair. And so you could have stepped, I'm going to guess you guys stepped right here. Am I correct? Yeah. And so you would pull out a 4, and then you would have square root of 5 left, and then this 4 comes down. If we look at what we had here, we pulled out 2 times 2. Is that the same as pulling out a 4, guys? Yeah. So depending on how you start these, they're going to look really different going all the way through. So it's not fair to sit there and compare your work to your neighbors or to compare your work to my work, but you need to look at those final answers. All right, ladies and gentlemen, let's do the on your own. Mr. Montgomery, I have not called you in all today, and you've had your hand up. So I am going to let you start off square root of 90 for us. How does that sound?
I had a question on that.
Okay, ask your question.
I got it down to
Well, how did you start it? Can we start there?
245.
2 and 45. I like it. What'd you do from there?
So 45 down to 95.
I like it.
9 to 3 and 3 and 8, 5 to 5.
Yep, 2 and 5 are prime. You're right.
2 times 2, 5
Ladies and gentlemen, I don't know if we've seen this before. Matt, what was your question?
2 times 2, 5
Exactly, because it says 2 times 5, so it is the 10 underneath there. And what did you put outside? 3. And is that okay? Yes! And that's going to happen. All right. Owen, talk us through B. 50 and 4. Nice place to start. What'd you do from there? Beautiful. I like it. Can I circle these 2's? Are you okay if I do that? I'm going to stop real quick. Someone asked me a question. They said, well, Mrs. Woodard, what if we were to have 3 2's? You can only circle pairs, and pair means 2. So even though there's this third 2 in here, I can only put 2 numbers in a circle. So that 2 is going to have to stay by itself for right now. What'd you do next? 25 is a perfect square. Beautiful. I like this because I knew we were going to have 2 perfect squares. So what did you have for a final answer? What did you do next, Owen? Oh, I see what you did. You brought this 5 down, and you did 5 squared. Okay, and 5 squared is 25. And then you have to multiply it by this 2 that came out. So did you end up with 50 here? Yep, and then the 2 stays under there. So do we have 50 square roots of 2? Well, I guess the only thing I would say is we check it if we don't agree. So I'm going to go to my calculator. I'm going to check 50 square roots of 2. Oh, that's not what I want. Let's check 50 square roots of 2. Let's see if Owen's right. 70.7106. The original problem was 5 square root of 200. Oh, I agree. Owen's perfect. 4 square root of 5. Well, if I do 4 square root of 5, I only get 8.9, so it's not going to work. So you've lost something somewhere. Sam. 25 square root of 8. And then what was our original problem again? 5 square root of 200. Ladies and gentlemen, Sam came up with a different answer, but it's the same decimal value. What the heck happened? Math Sam, you just broke all the rules. Math can only have one final answer. It can't always just have one final answer, but I do have to say this. Sam, I don't like your answer. I don't. And I hate saying that out loud. Like I had to, I almost blushed there because I felt bad. But, Sam, you are also my prize pupil for today. Because without your answer, I can't make a big point that I need to. Okay? So thank you. Ladies and gentlemen, can you all tell Sam thank you? Because this is a very common mistake. But let's show you what you need to do here. So, eyes back up front. Sam, can you tell me your answer again real quick? 25 square root of 8. All right. Ladies and gentlemen, the answer that Owen came up with was 50 square root of 2, correct? Does his 2 break down at all? No. So that's how I know this problem is done. Sam, could you break 8 down at all? What could you break 8 down into? 2 and 4, and then 4 would break down to 2 and 2. Did I just find another pair of factors in your answer? So what you want to do, ladies and gentlemen, is we can't simply go to the calculator and check. The first thing we have to do is we have to ask ourselves, does my number underneath the radical break down any farther? If it doesn't, like 2, 3, 5, 10 would only give you 5 and 2. If there's no more pairs underneath your radical, then yes, check that answer. But now what you need to do, Sam, is you need to take your 25, bring it down. Pull out your 2, and then put your 2 underneath. Does your answer turn into the same one we had? Which is why your answer checks on the calculator. We just have to watch out for that. So thank you. Izzy Miller was the star in my first hour. She did the same exact thing. So guys, it's really common to see that happen. I mean, Mr. Clum, we've been simplifying radicals in algebra 2, and we have students that'll do that. They'll check it on their calculator. They think they're done, but this 8 is awfully tricky. It catches a lot of kids off guard. Matt.
But in the first one where it's radical 90 and then
Which
was to 3 radical 10, that the 10.
But okay, guys. Matt just asked a good question. He said 10 breaks down, but is there a pair of factors there? No. It's not just whether or not it breaks down, it's can I break it down and still find pairs of factors? That's when you know that you're not done. Okay? But very good question. All right, ladies and gentlemen, backside, I've got a couple of more problems to do with you. All right. I'm going to multiply radicals. 2 square root of 8 times 3 square root of 10. I'm going to take 2 times 3, and I'm going to get 6. The rules there haven't changed. I then have to take 8 times 10. Now, what is 8 times 10? 80. And then what are you going to do with that 80 right away, ladies and gentlemen? Break it down. So instead of actually doing 8 times 10, this is what I do. I just write down 8 times 10. I don't actually multiply them together. 8 times 10 isn't a bad number. One of your problems today, you have to do 21 times 35. You start getting answers in the thousands. And not that that's not bad, but is that going to take us a while to break down something in the thousands? Yeah, but if I can keep them in nice 2-digit numbers, then great. So I'm going to take 8 and break it down into 4 times 2. I'm going to break 10 down into 2 times 5. There's a pair of 2's. 4 still breaks down. Don't miss that. And that breaks down into 2 times 2. So it doesn't look any different than the previous group of problems, other than the fact that I have to take 2 radicals and put those numbers together in the beginning of a factor tree. The 6 that we got, and where did I get this 6 from? Yeah? 2 and 3. That 6 is going to come down. This 2 is going to come out. This 2 is going to come out. And then 5 is going to stay underneath my radical because it doesn't have a pair. 6 times 2 is 12, and 12 times 2 is 24. It's not very neat. Why do you say bush? Because they just get kind of brown. Yeah? Yes? Because I'm going to go back to this. What's the square root of 4? Just a 2. So even though there's a pair of 2's there that made up the 4, when I actually ask someone what the square root of 4 is, it only comes out as a single 2. So these pairs are creating perfect squares that we're kind of discretely taking the square root of. So when you have a pair, you only write it down one time. Is that what you're asking, why I didn't have more 2's up there? Yeah. Okay. All right, so Alyssa, what am I going to do first here on number 6? 3 times 2 is 6. Good job. Jamie Campbell, what would I write underneath the radical?
196.
196. And what could 196 break down into? 7 times 28. Jamie, you can write it as that 196 and start breaking it down. And 196 is actually a pretty good number to have there. I'm going to write that down in just a minute so people can see things. But I also like the 7 times 28. I'll go back to Jamie's answer in just a minute, guys, because for this problem, that's a good way of looking at it. 7 can't break down, but can the 28 break down? Into what? I like 4 and 7. 2 and 14 would have worked, ladies and gentlemen, but did I just find my pair of 7s really quick?
Yeah.
Yeah. Am I done? No. 4 breaks down into 2 times 2. Is there anything to underline, ladies and gentlemen? No. Everything paired up. So I've got this 6 that comes down. I've got a 7 that's going to come out from that pair of 7s. I have the 2 that's going to come out. And what's 6 times 7 times 2? 84. Now, ladies and gentlemen, I said I was going to go back to what Jamie had there. We stopped our list of perfect squares at 169. That's 13 times 13. Does anyone know what 14 times 14 is? 196. This is a perfect square. So when Jamie multiplied them together, it happened for this problem that was a perfect square. So you could do 6 times 14. Actually, take that square root. I'm going to write it in a different color. Which is why, ladies and gentlemen, when I did my factor tree, did I have anything left underneath that radical? And when you have nothing left underneath the radical, you know it's a perfect square. And if you check on your calculator for me, 6 times 14 is 84. Julius?
I broke the 96 down into 49 and 4.
Yeah, and you wrote 49 and 4, and then 49 is a perfect square of 7 times 7, and 4 was 2 times 2. There's a lot of things you can do for that. But I wanted to point out to you guys why we didn't have anything left over is because that 196 was a perfect square. All right, ladies and gentlemen, you have 2 on your own. I would like you, all right, take a look. We have 2, and then we can write that as 5 times 10. It's going to break down to 5 times 2. We have a pair of 5s. So our 2 comes down. We have the 5 that can come out from the pair of 5s. And then 2 stays under there. So we should have 10 square root of 2. If we look at our example here, we're going to do 3 times 2 is 6. 6 times 6 from those. And right there is our pair of 6s. So we could pull those out. And 6 times 6 is 36.